The first topic we're going to talk about is what is the future of training export? Richard, do you want to just recap some of the things you were thinking about when we chatted about this, and then
Okay,
wanted to bring this up?
sure. I can give some context. The context is we're thinking about the export draft mode proposal, where we're going to propagate real tensors in our export program with fake tensors. And this is kind of difficult to design because you end up running into problems where if you propagate the fake tensors at the same time as real tensors, you might run into out of memory issues. If there are collectives in your exported program, then you might also just run into problems like just calling these real tensors with these collectives when you're exporting. These are problems that show up in a similar torch compile draft mode proposal. But I'm mostly just trying to figure out if export actually does have these problems. If it does, then we need to design around them. And part of the collectives and the memory usage story is that if you're doing export for training, then you might have these problems. And so that's why I want to know what exactly is going to happen for export for training to be able to design this fake tensor, this real tensor propagation story.
Okay,
So
so next I would call on you, Paul, to sort of say what the de facto current plan is. No projection out. Just like tell us
yeah,
about what is already like in the pipe.
yeah. So currently for export, it's a little different than Torch compile for collectives and stuff like that because for export we basically um, unflatten the torch rec modules that do collectives and stuff like that. So they just end up being eager, honestly. So we don't actually have to trace over them and capture the collective code and stuff like that. Unlike Torch export, I mean, unlike Torch compile, where you compile the whole, they want full mono compile the whole star stuff.
Okay, so another question is what do you do with the training IR? Like the export produces your graph with training IR. What are you going to do with that? Are you going to compile it later, or are you just going to run it?
You mean export produces the exported program, right?
Yes, yeah. And what are you going to do with it?
Yeah. So basically, what we do is we store metadata for the sparse modules, and then we end up just replacing the ones in the IR with just eager ones. So we regenerate the eager ones, and then we do sharding and model parallel and stuff like that for training.
You're regenerating an eager model from the export program.
The eager module, just the Tortrek modules,
Okay.
just those specific ones. Yeah.
Okay.
And
So it
then
never
some
goes into
specific
Inductor.
modules are being torch compiled. But I think the sparse arc is not one of the ones that are torch compiled.
Those are not one of the ones that are currently being torch compiled.
Okay, but you might run torch compile after you reconstruct the module.
Yes, but then it's just you're torch compiling the eager, just
okay.
Code.
Because part of the big TensorFlow draft mode thing is that there are custom ops that don't work with torch compile or torch export, and we're going to try to basically pretend that they work to give you an export program that works. Once you turn this into an eager module and then you torch compile it again, it will have the same problem. That the custom ops do not work with compile. So that's what I was trying to figure out. If the export draft mode idea needs to work with a compiled draft mode idea to actually work on a use case end to end. Sounds like the answer is yes.
Well, so just to ask some clarifying questions here. So, Paul, how read in are you on the recent discussion on red-green draft mode export that has been going around?
Yeah,
for, the past
I'm not
week?
very well read into that,
All
nor
right.
am I really that involved with Torch compile with the
Yeah,
sparse.
so let me go ahead and give another brief explanation of what's going on here. So there's been a recent thrust that started over at PDC, which is basically to make it a lot easier to get all the way to the end of the export process. So today, what's pretty typical when you're doing export is you hit a problem, you're stuck, you have to fix that problem, then you hit the next problem, and then you're stuck again, and you keep going again and again until you're done. So in the new model, which Richard is calling draft mode export, we instead do whatever we can to keep going so that we always can get to the end. And so instead of, so you get a graph, but then you also get a status report. It's like a test suite report which is either red or green. Green means, we actually managed to get through it with no problems. Red means there are a bunch of issues that we made potentially unsound assumptions to bypass. And that, if you care about making sure the graph actually works, you should work through those issues and make sure they're fixed before sending it off to end-to-end validation. So what exactly are we going to change technically to be able to have this capability? So there are a few things. So one is, we would be using non-strict export as opposed to strict export. That's already true. So non-strict is an example of heading in this direction, because when Dynamo breaks, you have to fix the Dynamo bug before you can keep going. Another example is the one Richard brought up, which is custom ops, which is that if you hit a custom op and there's not a meta function for it, normally we say you have to have a meta function for these things. We will be running real tensor propagation. So we can just, run the real tensor compute and then produce a bunch of real tensors, which we then turn into fake tensors to continue propagation. But basically, we will end up specializing for this specific input. This is what the operator does. And maybe this generalizes, maybe this doesn't. Richard, that's most of it, right? It's mostly real tensor prop right now that we're thinking about.
Yes.
Tuksu.
If the custom ops
go ahead.
already have meta functions,
then you're fine.
Then we're fine.
Yeah. The quick graph mode is to support custom ops that don't have meta functions.
Yeah.
Because
so
it's been a problem for people internally.
Yeah, I think so. With internal training workflows with export, I think we should be fine, because all of those ops have custom have meta functions, and if they don't, there's only a small subset that would just
okay
be there for us.
For context, for context, Paul is claiming this because this is used in the APS stack, which is a new thing.
Yes.
Which is a PyTorch native thing. It's a very different landscape when you are talking about Python models. Yeah.
So I have a question. So I understand we are trying to do real tensor prop. So why is it so why are we discussing training specific case here? Is there anything that's conflicting with the training IR today?
So I'm trying to design real tensor prop. As a part of designing it, I'm trying to figure out what the end-to-end workflow is. And one example of something that could be conflicting is if you have a custom op that doesn't have a meta, you export it, it works in this export, and then you need to compile the module that you just exported. And then there's no meta, compile doesn't see that you have no meta, and it's compiles what is going on. So drive mode export will not solve that end-to-end use case unless we plan and design for it.
Oh, I see. So in the training flow, there's torch compile afterwards. That's why we need to figure this out.
Well, my question was, is there a torch compile? And it sounds like yes, there is a torch compile.
I see.
So I actually don't know
By the
exactly.
way, this is not the only case where we do first to export and then to compile. There's another place where we have this weird workflow that is PT2E quantization, I want to say. It also first to export the graph and then, I don't know, quantize the weird training. So yeah.
Sherlock, how much AOTI also falls into that category?
AOTI is mostly used in inference, so it's less relevant to training workflow.
Oh, sorry, I meant as you do export and then compile.
It's just using the eager experience. So let me so what Paul was saying is first you have exported, you turn it into a graph, and then you serialize it, and during training you load it from the serialized exported program, you unflatten it, and then you do eager based transformation at place where you insert communication and do sharding. And after that, it just becomes a regular and kind of module where you do touch.compile for training. That's the workflow that, yeah.
Okay.
We have other questions, comments from the room?
So I think it would probably be good for us, Angela, to figure out where torch compiles happens in the workstream for APS, right? At least.
I think right now it's a config of FQN of modules that they specify they want to torch compile.
But before or after unflattening the IR?
After.
Oh, after. Okay, so we know that for a fact. So we know that we're just going to torch compile the eager module then. at
Yeah.
least for like the collectives and stuff you're asking about.
But to be clear, you're not actually torch compiling modules with collectives right now.
Not yet, no. Because I think that's the other work stream that you're involved in, Ed, with the full model.
So I think we're talking about a few things together. Like first thing is, how do we handle collectives in training IR? First of all, this thing is not a problem in APS because we export the single node on sharded thing. This is more of a problem if we're exporting a model that has collective building things like LLM inference, which would be more of a problem.
Speaking of LLM inference, do we have any status on distributed inference and export? Or is this just, we know it exists, but no one's touched it?
People are poking around, but I think the mainstream is still eager-based inference. Yeah. There's no, like, yeah.
Okay. Cheryl, you were saying we're handling a bunch of things, and you said handling collectives. What were your other things?
The other thing, I think like for training IR to really work, I think another thing that is important that is how do we handle subclass? Currently APS haven't raised this problem because, but I know that nested tensor training is in their roadmap. So down the road, they're gonna use training IR, and then they're gonna see nested tensor, and then because it's a pre-dispatch IR, this thing will just stay as nested tensor. I don't know even how to think about it. I know that like serialization currently doesn't work. We need to support nested tensor, tensor subclass serialization somehow. And I don't know even how to think about how they compose with torch.compile downstream. Yeah, and also like pre-dispatch tensor subclass export doesn't work today. Yeah, in order for STPA to be exportable in pre-dispatch IR, I heard you need to mess up with the torch function dispatch.
Yeah, torch function modes.
Yeah, torch function dispatch, and this doesn't exist today. Yeah.
Okay, well, sorry, Richard, is there something you want to get more resolution on? Otherwise, I'm going to like shift this conversation to the more future-facing one.
I mean, the overall question I have is draft mode export by itself useful? Or do we need to do this draft mode everything?
Well, let me answer that. Yes. Like, I don't need draft mode for compile. Like, I mean, draft mode for compile is useful, but draft mode export stands by itself. Simply, even just for use cases where, like, inference, right? Or like the big pile of like internal models that Sherlock has to migrate from TorchScript.
Right, but like if you need to do retracing on your export program, or if you need to apply compile after export, then like
no, but we're talking about this is like training IR, and
sure.
and you know, Paul has said in training IR situation, because we don't have this like huge build out thing going on. We actually like have metas for everything, and it's not a big problem,
sure.
Right? But then there's a bunch of inference things that are going to AOT inductor or going to Python predictor. Well, I don't even know how that's going to work. Like, you know, those, right, like usefully take advantage of draft mode export, even without the corresponding eager companion. And that doesn't mean we shouldn't work on eager compile draft. Like, I think there are like useful things there, but they don't have to, it's not one is pointless without the other.
Yeah. And I'll add another thing. I think draft mode, real tensor propagation have its own limitation. We just have to admit it. In particular, like if the model are too large to be fit into a single machine, then real tensor tracing won't work. And in addition, like in APS, the sparse weights are pretty large. So common practice is that people store it as meta device. So in order to make real tensor tracing work, you somehow need to put real weights, and that is kind of expensive, but I don't know, it's probably still doable. But I guess like if the direction that training people will want is make it work with a mix of real tensor and fake tensor. But like this essentially degenerate to fake tensor propagation. So I don't know. Like yeah, that's probably so yeah. I don't know how far real tensor tracing would go in training or training based export based training.
Giving Richard a moment.
I think I'm good on the questions.
You good on the questions? Okay. Let me think. 7 minutes left. All right. With the 6 minutes left, let's increase the scope a moment. Okay. So Richard, so let's say we actually want to like we're going to be ambitious. Specifically, I want something that will work for training export globally. So we're serious about training export. We want to do it a lot of places. What like should this look like in the limit? And so specifically, some questions to like sort of start the conversation include, I want to have my training export product actually end up being a pile of AOT inductor SOs. And let's limit ourselves to the online training case, which is just that I just want this, artifact thing that I run over and over, and that's it. Like that's the end of the story. Do people agree this is the right direction? Do you disagree? If you think it is the right direction, what are our challenges getting there? All right, so let me put some things out there. So, if I'm just going through the pieces that need to exist for this to happen. So one is I have a problem, which is what's my trainer in this world, right? When I do AOT inductor, I hook it up to predictor, but I'm doing training. I'm not doing predictor. So like, is my training script still going to be in Python? I guess it could be in Python. So, right. So my model then is I have to call into AOT inductor binary from this Python script, and then it gets me back out something. Maybe it just updates all the weights and I just call it over and over in a loop, ? Because one of the things that I want to do is I want the forward and backward to be all like wrapped up in here, right? So I don't think I want to call the AutoGrad engine in this regime.
So you are talking about joint graph.
I am talking about joint graph, yes.
Okay.
Including optimizers?
I don't know. Let's say we don't include the optimizer. So the optimizer can be separable. But maybe long term I do want to include optimizer too.
Yeah, I would ask why not.
Sure, let's include optimizer too. And then what are some other things I need to solve? So in this model, I actually have solved some of Sherlock's problems. So I don't have Sherlock's subclass problem anymore because I've sufficiently captured enough that the subclasses are kind of irrelevant here. The other thing that I can think of, just sort of stepping through this, is these binaries don't know the topology. So I basically have to have made my sharding decision. Like if I'm doing a full recommendation model training, like we're doing in APS today, I need a pre-commit to the sharding. Can we do that? Are we okay with doing that? I also need torch compile to work on the entire thing. Whereas like with export, you stub things out and then you don't have to torch compile everything.
Yeah, there's a problem with this approach. You assume that the sharding is predetermined and it is fixed. But in practice, this is not like, and people want to do experiment. So what people do is export the graph, and then you do all kind of sharding, all kind of FSTP experiments, depending on currently how many results you have. You may still want to run the job, but like it's a bit slower. But here's the resources, so it's so.
But
People
if this is
still
just
want
for
to do the
online
kind of model.
training, then I don't have those constraints, right? Is it bad for it to be different? Maybe it is bad for it to be different, and I need online and offline to like look the same.
Yeah, like we can say in the contiguous training case, where you do recurrent thing, I would more like to think of this as an inference like workflow, where you have the binary thing, it's frozen and you just do it again and again. But for the online, I don't know what like offline training thing, which is like you still need kind of flexibility on how you configure the training job.
Okay, so what I'm hearing from you is even if we did this, at most its applicability would be for recurring and online flows. And for offline training, you would still like to slap a torch compile on top afterwards so that you don't have to do I'm not even sure. You don't have to do the full export process. I mean, I guess that makes sense. No, but that's...
Yeah, I'm actually curious, Ed, what do you get if the end result is you run a Python script with torch compile? Why are we going through the whole export process here?
Oh, so why does export IR for APS exist today? Well, Paul, do you want to explain?
Yeah, pretty much it's just a deprecation of torch package here, right? And they want an artifact where it's like, this is the model instead of relying on code as the model, pretty much.
But, okay, and so the Python script that will run that model will be a very generic runner script that is not specifically for this model, but is like a kind of library that we upgrade independently of the model.
Yeah, I would also say just one thing to add from my perspective, sharding even in offline recurring training does not change very much. In fact, like I'm pretty sure a lot of ads models have pre-configured sharding plans because if you change it a lot, it can end up affecting NE and stuff, and like you don't want that. So usually it's very static, I would say. The model parallel sharding stuff.
Yeah, I would also be curious to what extent dynamic shape saves us if the only problem is really sharding of the parameters, because dynamic shape can handle one dimension changing on one parameter if we set that up properly, or if we actually do not want to bake in too much of the std information into the graph, which would be trickier.
Yeah, so to circle back, Sherlock, I think I actually reject your claim. Like, I think if you went through all the trouble of making your thing exportable to replace torch package, then I think you should just go all the way and like bundle in the sharding and then just end up with some binary which gets loaded for the training. Assuming all the other stuff works, which it doesn't, but like, if it did.
Maybe.
I also say
I don't know what's happening in training workflow today. Like, if I just do one shot all the way to .so.
I mean, so I'd also say like this workflow of like multiple exports and changing stuff. Like my advice to most people would be don't do that. Like this is sort of an insane workflow, and I get that like there's specific internal people who do, but like I think the common use case of PyTorch, like there's just much simpler ways to organize your flows that just don't create all these problems that you need to fix. Like I feel like most of these problems are sort of self-inflicted wounds, and we should be strongly advising people not to do this.
Jansel, since I have you on the line, so do you think exporting straight to a single training binary is a reasonable workflow?
I feel like the common, like if I think about like okay like what's the motivation here? Like if I have this massive cluster of tens or hundreds of thousands of GPUs, I don't want to spend any compile time where the GPUs are all idle. There's like a utilization problem. So I think like the thing to do is you like we have like good support for ahead of time compilation. We ship the ahead of time compilations to the cluster so that the cluster isn't idle and we're not wasting cycles. And I think that can be achieved through much simpler mechanisms than this sort of like multi-step export where you like export and reconfigure I think you can do it sort of in like a one-shot, like, okay, like I have one machine, I prepare the binary that I'm going to ship to my massive cluster, and then you hit go and you go.
Okay, I'm going to take that as a vote of support. Okay, we don't need to solve all the problems here today, but yeah, this is part of the also discussion.
I think a more reasonable workflow that this applies to is actually privacy training on edge, which you have a joint graph and then it is fixed, and then you can have a single binary just drawing that joint graph and deploy it in edge. Yeah.
Okay, so since Paul needs to go, oh, he's already gone. I'm going to move the topic along. Yeah, that's fine. To the second topic for today, which is the one Will is spearheading, but he's not here. But I'm going to represent. By the way, I don't 100% agree with everything in his proposal doc, but I think it's a good place to start the conversation. So, like, this is like very early, and we can change a lot of things. So let me just go ahead and share my screen. And let me get the OBS folks here as well. Okay. So, all right. So what is going on with this proposal? So before I tell you the proposal, let me tell you about some of the problems we're trying to solve. So problem one, this is Will Feng's problem. They've got this cool thing, FSDP2, but they have a problem, which is that they can't torch compile it on the very first run through. They have to, for technical reasons, because FSDP2 has a bunch of initialization logic that you don't really want to like torch compile. They need to run it in plain eager mode first. And then once you've run it in plain eager mode, then you go ahead and actually turn on torch compile for everything. Okay, so that's use case one. And unfortunately, I can't really represent why the initialization logic has to be done in eager mode, but maybe someone else here can if there are questions about that. Okay, a second one, which is also from Will, is delayed scaling and FP8 training. So this is essentially, hey, AMAXs aren't initialized ahead of time when you do the first iteration. So make sure they get initialized and then run your thing. One thing that I will say is that this pattern where there's like code that just kind of does something different in eager the first time around, it's pretty common. There's also examples of this in FPGem all over. Like I think it's a reasonable thing to say is that if you're just dealing with an arbitrary Python library that wasn't written with torch compile in mind, it's pretty common to like have some initialization code on the first iteration that you're gonna have to do something about. We even have some of this in core library as well. Like lazy module is another example of this kind of pattern. Okay, so switching tack for a moment. So another use case is the quiescence use case. So quiescence is this old API that's been in PD2 since the very beginning that no one's really ever used for some reason, which basically says, after some amount of time, I expect all the compilation I need to have done to be done. So I want to say, okay, no more compiling, just stop and raise an error if another compilation triggers, because I want to like raise an error and I don't want to I don't want to like later get a nickel timeout or something because like some ranks compiled and some ranks didn't. So the way this API was originally formulated was there was a function call which you called to like trigger quiescence. But one thing that I noticed when Will was proposing his other APIs is I was like, well, you know, there's a similarity, right? Which is like, I want to somehow be able to talk about like how much time has passed in my model, like how many steps or like units of, you know, compute have happened. And only after some number do I want to do things. And like actually instrumenting my training loop to like do this manually, I can do that. But then I have to do that on every single training loop that I want to do. So is there like a more generic API that can apply in a lot of situations? And the final one is eager warmup for async compilation. So we can talk about this a bunch. It'll require some implementation work, but essentially the pitch here is that when you want to torch compile a model, what we'll say is actually for the first n iterations, for the first n steps, we're going to run in eager mode. But it's special. What we're going to do is we're going to run Dynamo the very first time, or, you know, after you've done your eager warm-up, if you needed one, that. This is a different eager warm-up. Then we're going to Dynamo it and use the Dynamo run to kick off an async compilation process. But then we're going to keep going. We're not going to wait for the async compilation process. And we'll run some number of iterations before then we block on the async compilation process finishing so that we actually can run the compiled code. And once again, this is sort of situation where it's like, you know, I need to say how many eager iterations I'm going to do. And then at that point in time, I want to do the cutover. And I need to design an API for this sort of thing. Questions about the motivation, these use cases?
Just a question for you is, I can see like one more reason to do this, and like warm up stage would be great for the optimizer step if you wanted like a full graph thing too, of like initializing the optimizer state, calling one step. So that's just
Great.
like one more.
There's another use case, and I just realized I forgot another one, which is CUDA graph breaking. So CUDA graph tree breaking is basically when you're sort of done with like the iteration and you're going to like start again from the beginning of the CUDA graph tree, there's a point in time which you want to say, I am promising that I'm not going to use any live tensors anymore, and like so I can clobber them for my subsequent CUDA graph record. So there's actually like a step API in CUDA graphs specifically for this case as well.
Just to chime in, for that, we need to know prior to beginning the step. So it's like mark step begin, and at least in the API design here, it seems like we're using it after the step has ended. It feels like, you know, if you mark the step, you'll know when the end has. If you mark the beginning, you'll know when we've like finished our first run. But you know, marking the end won't tell you when you're starting your first run. So
yeah, so there's some flex here. I got
Mhm.
some recommendations that we should mark both the start and the end of a step. So that might be one way to like handle this situation. Maybe that recommendation was from you, Elias. So
or just the beginning. I mean, if you mark the beginning twice, don't you know the end on the second invocation of the beginning?
Okay, I don't remember who suggested this. Maybe if you're here, you can recommend.
I think that might be interesting to look at this as a context manager to table some of these discussions. And I think the other use case we have here might be profiler willing to know exactly these kind of things. And I think you said there is existing code that does that already as well.
Okay, so I'm going to present Will's design, but I'll also talk about the other like variants we had here. So there are 2 points to the API design. So point 1 to the API design is we have some configs that tell you like when you want to trigger things. Like how many times should you run eager? How many times should you run while waiting for the async compilation to finish? How many times should you allow for compilation before you quiesce the model and say no more compilations? And we want this API to just be numbers. So you say, well, do one warm-up step, then do 5. I don't even know what these configs are, but like do 1 warm-up step, do 5 steps waiting for async compile, do 10 steps where you're willing to compile, and then that's it, right? And so they can either be like absolute indices or relative indices, and we have some like global timeline ordering. So if you add another like phase, then we can squeeze it in there. I don't have a big pre-commitment on exactly how to do this. And how exactly does the API look? So the first version that we have in here is there's a function you call at the end of your step that says when the like unit of accounting ticks forward. We can also do a context manager. That's like a fairly easy change as well. I don't know what this is. Okay, this is just saying how, you know, like as the steps increase, you know, you're consulting the configs and then things change as you go. There's actually a funny overhead problem which we should worry about, but we can get to that when we get to that. With Alvin, give me a name for the context manager. I don't know. I have no idea.
I don't know. Let's say compute. Not compute. Yeah.
I have no idea. Whatever.
Compute scope. Yeah.
Jansel?
Yeah. So this like sort of feels like going down the road of like managing the user's training loop, because like
yes.
one thing that you could do, an alternate API to this would be we like provide like a trainer class, and the trainer class sort of manages the outer loop, because there's lots of other stuff you might want to do in a training loop. Like you might want to start like preloading the next batch's data in a background thread. You know, you might want to, you know, have like you know, logging where you like log the loss over time, and you know every n iterations you know do an evaluation step or you do a you know you do an evaluation to sort of see like how your holdout loss is going, and sort of like a lot of these types of things feel like stuff that sort of and then this is something a lot of users will do, and I'm sure there's open source alternatives for this. Like these are sort of like the training process management type stuff, which like I think like PyTorch like traditionally has sort of forced the user to write this loop. But you know, if we sort of had like a canonical like trainer class that sort of managed this stuff, these would all be like configuration flags to that trainer class. And having sort of the user still write the trainer class, but then have all this sort of implicit behavior that happens under the hood because we don't control the trainer class, sort of seems like sort of the worst of both worlds design to me.
NYC.
I guess the historical reason why we don't provide that is, I think, the trainer is a very opinionated part of the code base, and I don't think we've seen any broad alignment on a single trainer, even within Meta.
But this type of stuff, like I feel like all the stuff being proposed here feels like in that very opinionated bucket. Like, okay, should you do background compilation? You know, how long, how many iterations? How should it coalesce? Like a lot of these, like this sort of feels like solidly in the opinionated bucket.
Yeah, which is the problem, I would argue. Like, how are we going to align this with the Accelerate, with TNT, with Ignite, however many other internal things we have, would be my question. I think that this proposal we can relatively easily integrate with existing trainers, and I think we can work with them to integrate that. But if we go all the way and create our own, then it's like we need to for everyone to migrate to our own trainer now. Do you think that's the interesting direction to go into?
When I was sort of saying like build like this sort of feels like building a trainer class, I wasn't necessarily saying we should build a trainer class. I'm just saying like it sort of feels like it clashes with the design philosophy. Because sort of our design philosophy has been like, okay, well, everyone writes their own trainer class, or everyone, or people will like build sort of out of tree trainer classes and then use those. And these sort of like management decisions of like, how does warm up work, feel like they should be owned by the trainer class component, and we've decided to let someone else build that. And so like it feels like the sort of like if we've decided that the training loop is owned by someone else, like that decision of how one thing like an API that sort of give control to the user would be, okay, there's a run mode in Dynamo which doesn't do any compiles. There's a compile mode, and maybe like just the outer trainer loop decides whether we should be compiling, and the API we expose is just like, okay, like should we stop compiling and fall back to eager? Should we stop compiling an error if there is a compile? And just have it just basically like rather than having sort of like some secret counter in PyTorch that changes this behavior, just have the trainer loop tell us, because the trainer loop is managing all the warm up for us.
I think Ed has an answer to this one because I asked a similar question.
Oh no, Albin, you represented the point of view. Also, I also agree with Jansel's thing. One of the reasons why I told Will we needed to bring this to the room is because it is a philosophical step away from the trainer is not our problem. So like I think Jansel's alternate design is an important one to think about. By the way, funnily enough, we are independently having another discussion about this context manager, so one of the context managers, which is the run it in eager mode, is I have proposed that we do this instead of the change in the disable. So this is like Torch compiler force uncompiled, which says, hey, for all the compile invocations inside of this region, don't actually compile them, run them as eager. So actually there is, there's some independent appetite for this API. Albin, why don't you ask your other question?
No, I think playing devil, I 100% agree with you, Jason. I think the point that Ed made was the problem with providing these as a collection of features that the trainer has to use internally is that we have to update the trainer code every time we do one of these. And I think Ed was mentioning, I just want to have a hook. I put in a trainer and then I can keep adding features to that hook, which I think from an integration point of view, I agree internally would make things easier. I also agree with you, Jason, that it would make things simpler if we have explicit APIs, and for the trainer, where this logic lives, for them to control it.
So Alvin, just about the hooks thing. So like taking Jansel's API for a moment, because these are context managers that we manage, we can put like we have the ability to put stuff in here, right?
Okay, sorry, no. Well, can you repeat that?
So I turned Jansel's proposal into a concrete one, which is we have 4 context managers, right? One that forces eager mode, one that's like start doing async compilation while this thing is going, one that's like now you're compiling, and then one which is the quiescent mode, right? So we like if you only ever need to like insert from the framework extra code to run during these cases, then as long as the trainer is calling these modes, you're safe in the sense that like
There might actually be two versions of the no more compile mode. There's no more compile and it's an error if we compile, and no more compile and we fall back to eager.
Yeah. So one thing that I will agree with you is that it does seem one of the things that like kind of was nice about this is it's a very small change to the it's a very small change to the trainer, and then like this stuff can live in library mode. Whereas if you say you only give these 4 functions, then it's a little more of an involved change, right? You got to do the like step counting and stuff if you think a step API is the right thing. Maybe we could make a separate library, torch train utils. I don't know. Sounds terrible when I put it that way. Which would hold the like higher level concept. But yeah, I don't know. Like,
Isn't that Torch Vitals?
Torch Vitals? I don't know. Is it? Does anyone use Torch Vitals?
I don't know. I don't know what it is. It's a nice name.
Let's ask the rest of the room. Any comments? Thoughts? Should I call on people? Yeah, I'm gonna call on people. Animesh, what do you think?
I like the 4 APIs. I feel if user is going to change the user code should not change that much. Like the user is going to add a context manager anyway. So if the user can say, oh, if step is less than 10, do this. If step is between 10 and 20, do that. It's not that egregious. It's bad, but not that bad, in my opinion.
Maybe Elias, do you have any feedback on how the mark step for CUDA went? Was that actually a pain to integrate with the different trainer code, or did that go relatively smoothly?
It was not too difficult. I mean, the error message, there's a clear error message if you don't use it that suggests the usage, and then people integrated it to their training loop, not as a context manager or anything, just as API call. And yeah, I mean, there was like some questions from users like, oh, will this have any overhead or anything? And I was like, there's no overhead to it. So it hasn't been too bad.
So if I wanted to look for these use sites, what would I search for?
CUDA mark step again, I believe.
I'm gonna call on more people. Do we have anyone from Torch Tune? Okay, Ivan, are you listening right now? You come from Torch Track. What do you have any thoughts about this discussion?
I would say that people usually like to use like prepared train pipeline, especially if it needs something additional like pipelining or like yeah. So it's so I think like, in terms of like other libraries, how is it called? Torch. It's like it's pretty popular library that also like implements like just like training loops like without like popular bugs. Yeah, so it's Torch Lightning. Yeah, so it's Torch Lightning like is pretty popular just because like it implements like some like next step like of abstraction like on the top of PyTorch. So I would say it will find users like and users will like it like if it will be implemented.
Are these like sorry,
Go for it.
I just say like is the usage of these context managers like obvious, I guess? Like especially I'm just thinking of delayed scaling case. Like we could say, hey, if you're using compile, mark this region. Um, but I feel like it's not like a super obvious like thing.
I certainly agree that it requires a little more code than I would like to add this to the call sites because you have to like do the counting and then you have to do the swapping by yourself. So I don't know. Animesh?
Yeah, if the counting happened internally in our implementation, I think the debugging is harder. If user makes a change in the code, the user can print, oh, I'm completed like eager mode, I've completed async compile mode, I've completed this this no more recompile mode. And the tweaking becomes much easier. I'm pretty sure people will start tweaking, they'll think, oh, I don't I thought there would be no more recompilations, but I need one more recompilation. And that kind of debugging would be hard because it will be difficult to control logging if everything is very internal.
Any final comments? Otherwise, I'm gonna wrap up the convo. All right. So I think my resolution here, which I'm going to bring to Will, is that explicit is better. We should finish designing the rest of these context managers. Should they be context managers? I don't know. Probably context managers. We will provide and context managers for phases.
If we're gonna go context managers, I might suggest like maybe one context manager, because I'm thinking about like what does this training loop that the user writes look like, and passing a flag to like one context manager is probably easier than like having like a big switch statement to decide what context manager to use.
Okay, so we'll have one context manager, and it has a flag saying what phase you're in, and the user will be expected to change the phase as appropriate for their logic. NYC?
Yeah, is that similar to kind of like our profiler logic of like warm up steps, active steps, blah 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 steps? I think if we do something like that, it's like familiar to people already. So I would +1. But my question was like, is it possible to do that? Like, is it super linear where you're gonna move from, I guess, eager mode to async compile to no more compile? Like is it always, does that encapsulate all cases that are above already?
So there is a funny interaction here. So eager mode, compile mode, and no compile mode are stateless in the sense that like they have self-contained semantics, right? Eager mode is like don't do anything when you hit Twitch compiles. Compile mode is basically our default mode today, and no more compile mode is like, you know, set a flag that causes you to error or fall back to eager when a compilation is triggered. Async compile mode is a little persnickety because this one like you're saying I'm going to do something at the end of the context manager, but this is still possible, I guess. But this one is like you actually kind of don't want to like. This one can't as easily be done as a context manager. You need some state where it's like, yeah, I'm like booking these steps until you get to the end.
Yeah, I guess the question I had was I wasn't sure if you could go from like compile mode to no more compile mode and then back to compile mode. The one context manager feels great if you could define.
Yeah,
like,
so for these three you can. Like there's nothing stopping you from swapping between them. Async compile eager is weird, and maybe that should be its own thing. I'm not sure.
Okay.
Okay, that is time. All right, thank you everyone.